All right, Integrated Math 3 students, we are starting our new unit today. In your notebooks, I would like you to go ahead and start a new page and write Unit 2 Factoring, okay? And before we get into this, I have something pretty serious that I want to talk about with you guys. So I'm going to go full camera for this. All right. So, factoring is a skill. Okay, that's all it is. There's not like deep concepts that are going to be gone into about factoring. Okay, and you already have your assignment up on Delta Math. So let me show you this right here. Okay, this is a student without any instruction, because this is due next Friday, has already completed everything. I have not made a single video over this. All right. Now, if I highlight over these, you can see how long it took to do each one. And this is factoring cubics. We've never learned that. You've never seen that in another class. Here we have factoring by grouping, a similar amount of time. Okay. So I'm going to use the words additional help in this instance. You are distance learners. You have access to additional help, okay? Now, if you use so much help that you actually are not learning the topic, then we have a problem, all right? You're not actually learning anything. And that's all I care about, is that you're actually learning. Let me go full camera. All that I care about is that you know how to do these things when you come back to school, when you take ACT for the first time, that you have these schools built, all right? This showing 27 seconds. Now, obviously the kid could be very sharp at math, but I could not do these questions in 21 seconds. Some of the ones that we're seeing here, okay? There's one that's 16 seconds, okay? For factoring cubics and having an equation. There's no way that I could ever do that by hand, that fast. So, additional help, I believe, is being used for this. And I believe that the student truly does not know how to do it. If I gave them one problem and said, show me how, okay? So it is time for an integrity check. All right, what does that mean? Well, you guys are at home, all right? And this is me as your teacher, somebody who is investing in you, going through all this process to make these videos, spend additional time outside of school to do this for you guys. And when I see something like this, this makes me feel like useless in a way, okay? That's really what it does, and it's very disrespectful to me that this is happening. Now, hopefully you guys understand how respect works. I'm going to respect you guys to use whatever help you need to learn the concept, and hopefully you guys respect the fact that I'm putting in a lot of time in these videos. So what I'm going to put in this video is really an integrity check for you guys, all right? I need you to type in your name, and this is you committing that you will only use additional help to learn how to do the concepts, not to complete these assignments. All right? If you are taking this amount of time to do these questions, that is evidence to me that you are not learning the way you need to be learning. All right? So I'm going to put up a little statement in the video. You are going to sign that with your first and last name, committing to me that you are going to genuinely do this work and genuinely learn. If you're confused, you'll ask questions. That's how we learn, okay? We don't seek additional help, the wrong type of additional help. You seek me out, or go watch extra videos on the processes for it, all right? Because doing what I think is happening here is not going to cut it. Okay, and when you come back, those of you that are, for this next 9 weeks, and let's say the next test you have to know how to do these factorings. And then you're like, oh, I forgot how to do it. Well, no, you never actually learned it if you did it this way, okay? So, please go ahead and sign this now. That is my spill. Now, let's get into the concept, into the learning, okay? Factoring. Here's how you need to think about factoring. Let's give it another name. Let's call it, oops, hold on. Let's call it, put a quotation mark, polynomial gymnastics. Right, well, what do I mean by that? Well, we are going to take polynomials and contort them into other forms. We're going to use special moves to change from one form to another, and that's really the goal here. This is a skill. If you know how to do a backflip, you had to practice it, right? So if we're doing a backflip, quotes, right, you need to practice how to do a backflip. Don't find the wrong kind of help like we just talked about. Learn how to do it, so then when it comes time to actually prove yourself, you don't look like a fool. Okay? So the first type of factoring that we're going to talk about, you've seen it before. It's called greatest common factor. So we'll underline that. This is also known as GCF. This is going to go into what we're going to call your factoring toolbox, okay? When you're interpreting a question, you go through your toolbox and you say, oh, I think GCF can be used on this. It's just like fixing something. If you're looking at, if you're fixing something and you need a screwdriver, you know what type you need. You're looking in your toolbox and you're like, okay, a hammer would not work for this problem. Let me go grab a screwdriver, okay? That's sort of what we're talking about here and the mindset you need to have. So greatest common factor. Let's start with the idea. We're gonna start simple, okay? So we'll just start with numbers. All right. So what is the GCF of? Let's go with 8, and let's go with what number do I want? Let's go 36. There we go. What is the greatest common factor? I'm going to put a question in here. I'm going to pause and you can fill in your free response. GCF of 8 and 36. All right, so you had time to think about it and answer. You should have said that the GCF, what is the greatest common factor? Well, if we list out all the factors, we know 1 and 8, 2 and 4. There's no more there. Here we have 1, 36, 2 and that would be 18. Does 3 go into this? Yes, 3 and 12. 4 and 9, 6 and 6. So that one has a lot more factors. All right, what is the greatest common factor if we look at all of these that they share? Well, 8 is the greatest on this one, but is there an 8 over here? There's not. Okay, so then we go to the next highest, 4. And I see a 4 here. So the GCF that you should have put is 4. It's their common factor. All right? So that's the mindset that you want to be in. Obviously, it's going to be more complicated than this when we get into it because we're dealing with polynomials. So let's try another example. What is the GCF? What is our GCF when we take, let's go with 3x squared, and then let's go with 12x. So now we have complicated things a little bit. I'm not going to ask a question about it because I think that this one's going to be a little challenging, but maybe some of you have it. But do you know what the number GCF is? If we're looking at both expressions here, we're not going to break them down like we did over here. Not necessarily. I mean, we could do that, but we need to get to a point to where we can just look at this, look at the numbers, and then look at the variables and say, okay, what is their common factor? So let's write some steps. So for GCF, do numbers first. And then variables second. And that's really all we're going to have to be doing for this. So we start with the numbers 3 and 12. What is the GCF of 3 and 12? Well, what's the highest number that can be divided into both? Well, 3. Okay? 3. Now we look at the variables. So we have x squared and x. Okay, so think about it this way. We're talking about variables, and I'm going to put a little tick mark here. The most that can be divided away from each term. How many can I divide away from each? We're just talking about the x values. Well, there's two x's here, x squared, so it's x times x, and then this is just one x. So could I take two x's away from it? Well, no, there's not two on the right side over here. So what is the most that I could take out from each one? Well, that would be x, right? Take an x from here, take an x from here. This is the GCF that we wanted. So that's just identifying GCF, all right? That's not necessarily answering the question or working through the problems that you're gonna have on Delta Math. Here is an example of the problem type that you're gonna have. So example 1. So that was just sort of notes up top. We're gonna write some more steps here. So we'll have step 3 in a second, okay? But let's go ahead and write down a problem. 12a to the third plus 10a squared. So now we have an addition symbol in here, and this is what actual problems are gonna look like. This is a polynomial. It's a binomial, technically. And we're looking for the GCF. So what is the GCF of 12 and 10? That's what you need to think about. So when you're at home thinking, okay, what numbers go into this? 12 and 10. Well, obviously 2 works, but does any other number work? 5 goes into 10, but not 12, so it looks like it's gonna be 2, okay? Then, same idea with the variables like we did up here. How many can you take away or divide away from each one? That's what we wanna know. Well, there's 3 here and 2 here, so the most that we could divide away is 2. So I'm gonna put a squared. So there's our GCF, but we're not done with the question. So when you're going on Delta Math, this is what it's gonna want you to do. It's going to want you to put it into a final form because there's still numbers that are left when I factor out this. So we're gonna write step 3 over here, okay? When you decide the GCF, we're gonna factor out, I'm gonna call it that, factor out the GCF and leave the remaining terms in parentheses. Okay, so we're gonna put parentheses here. We have terms that we started with, but now we're changing. Again, this is polynomial gymnastics. We're taking this equation up here. We're taking this equation up here and we're converting it into a new form. We are doing a backflip, right? We're switching it up. We're taking it and we're performing moves on it. We're using our tool to manipulate it and change the way it looks. So we've divided out this 2a squared. So let's think about this. Let's start with the numbers again. 12 divided by 2. Well, that's going to be 6. What happens when I have 3 a's up here, a to the third? When I divide out 2 of them, that leaves just 1. Okay? So 6a is inside. This became this. All right? These terms go inside. I still have this plus sign. It gets dropped down. Okay? Now, we want to do the same thing with the 10a squared. We want to divide away the 2a squared. So 10 divided by 2, that's 5. What about a squared? There's 2 of them, and I divide away 2 of them. So there's really none left. And actually, this question is done. We are finished with this question. This is our answer. We got it, okay? Let's look at one more example, and then we'll just talk about Delta Math just to make sure you're clear on what that's going to look like. So example 2, we have 14m to the 8th n to the 5th minus 7m squared n squared. So we have here, this one is a little more complex, right? There's more variables. We're going to treat it the same way. The first thing we want to do is we want to check the numbers, 14 and 7. What is the GCF of 14 and 7? Hopefully you're thinking, oh, 7, right? 7 goes into 14. I can divide 7 by itself. That works, and that would be correct. So 7 goes here. Next, look at m to the 8th, m to the 2nd. How many could I take from both? Okay. Well, the most that happen from both of them is square. So I'm going to take out m squared. Then we have n to the 5th, n squared. The highest amount that I could take or divide away is n squared. Okay? So that is our GCF. That's the process for finding your greatest common factor. But remember, we didn't divide everything away. We just took part of it, the most that we could, the greatest amount that we could. So we still have what remains in parentheses. So we go one piece at a time, start with the number 7 divided away from 14. That's what we're doing. We're dividing these things away. It's not subtraction, it's division. So 14 divided by 7 should get us 2. M squared, we had m to the 8. We're dividing away 2 of them, okay? So we're almost, it's not necessarily subtraction, we're subtracting the exponents, but this is division. So I'm dividing away 2 of them. So 8, okay, divide away 2 of them. It is sort of a subtraction type deal. This will be m to the 6th, okay? N to the 5th, we're dividing away 2. That's n to the 3rd. So that's that first term. It became this right here, okay, from dividing. Now we want to get this one. 7 divided by 7, what is that? That's a 1, right? Let me put my subtraction symbol. M squared divided into m squared. When you do that, anything divided by itself is 1, so it's 1. N squared divided into m squared, that's 1. So all of these terms actually get divided away. This one is the GCF, so it becomes 1. And that now we have our answer. This is our final answer, okay? Let's look at a delta math problem, okay? Get some of these skills. So greatest common factor, multivariable, boom. We got a pretty complicated one right here, but that's okay. Let's go ahead and I'll write on this. Let's do the same process. First off, let's start with the number. What is the GCF? Well, -34, what's the number here? Well, it's a 1, right? What's the GCF? Well, it's just 1. So I can't really take out a 1. I'll write it just because, but I could get away with not writing it. So these numbers are going to stay the same. Now we look at the variables. Look at both of them. This side and the other side, okay? So we want this one and this one. Look at the x's. How many x's can I divide away? Well, the most here is 2, the most here is 4. So 2 is going to be the most. So I'm going to put x squared. What's the most y values that I could take out? Well, y squared and y to the 4th. So it's the same amount, y to the 2nd. Then we have z to the 5th, z to the 4th. What's the most that can be divided away? Well, that'd be z to the 4th. Okay? There's my GCF. Now the answer, it doesn't want that. All right, we have to make sure that we have our parentheses as well. So what is the first term going to be? Well, I didn't divide away anything for the numbers, so -34 is going to be in there. I probably need more space. Hold on. I'll write that in a second. Let me move this. -34. Okay, what happens to these variables? Well, I divided away an x squared, so this became x to the 2nd. I divided away a y squared, so that's y to the 2nd. I divide away 4 of the z's, so this is z to the 1st, right? So we have that first term. Now we put the subtraction. What happened over here? Well, I divided away all the x's, so that becomes 1. I divide away all the y's, so that becomes 1. I divide away all the z's, so that becomes 1. So really this whole entire term just becomes 1. So let's see how we type this in. Let's see what we need to do to get that typed in and our answer correct. So I'm gonna move this over and we'll just show this. Let me do this right here. There we go. Slide that. All right. So again, I don't need this 1 that's up here. So I'll move that back over. I don't need that 1. So I'm just gonna put x squared. So x squared, y squared. You can type the letter Z from your keyboard, not squared, but to the, we need to the fourth right there. Then we go down and we need our parentheses. We're going to type all this in, negative 34 x squared y squared. We don't need the first power. The Z is it. You don't have to show that power. Every number has the power of 1. Then we're going to put minus the 1. Let's see if it likes this once it loads. All right, so let's check it out. Submit. Got it. Okay. So it goes through the GCFs. If you miss it, you can check your work pretty easily. It's going to tell you what the GCFs are. And it goes through how to solve it. It shows like the steps that we're doing in our head where you're subtracting the exponents. Oh, they actually factored out the negative. So they took this negative out. We don't have to worry about that, obviously, because it didn't get it wrong. So I'm fine with that. All right, that is GCF. Again, it's one of our tools for factoring. All right. Now, I want to talk about multi-step factoring. These are not, okay, I'm going to do this question here. So I'm probably going to shift this one down for after a certain topic, but this problem has GCF and it has a factoring skill that we know from before. So let's work this one here. I would actually like you to write this in your notes. Let's call this example 3, unless you wrote the last one from Delta Math in there. So let's look at all 3 terms. Instead of just 2, now we have 3. All right. And moving forward, you always want to be looking for GCF. That could always be an option for us when we're doing our factoring. So we want to change the format of this. Look at all of these numbers. -5, 45, -90. Okay. So what is the GCF of this? That's what we want to know. What is the GCF? Well, 5, 45, and 90, I believe that 5 is going to go into all of them. So I'm going to start with that. Let's write 5. Now, I also want you to notice that there's a negative up here. Usually, just like the last problem we saw, if you can factor out a negative from that first term, that's usually you want to do it, okay? So we're going to say that if, write this down in your notes, if, and put a star, the lead coefficient is negative, factor out a negative. So we're going to put a negative on this 5. So the -5 there. Let's look at the variable. We have x cubed, x squared, and x. What is the largest amount of x's that I can take from each one? Well, since this one only has 1, I can't take 2 or 3 from it. So I'm going to be able to take 1 from each. There's nothing else that I can take from this. So now we're ready for that third step, which is put it in parentheses, okay? And we're going to take each term. So -5 divided by -5 is +1, right? X cubed divided by x, we're subtracting 1x away essentially. This is x squared, so 1x squared. 45, that's positive 45 divided by -5. What's 45 divided by -5? Well, that should be -9. The x values we divide and we get x. And then lastly, -90 divided by -5. Well, if you don't know that's not even times tables that we get to. So let me pull up my calculator just to 90 divided by 5 should be 18. Now look, this one was negative and we're dividing away a negative. So we end up with a positive number. So plus 18. What about the variable? X dividing into x, that just becomes 1. So this is the first part of our factoring. Now you'll notice the topic says multi-step, because we're actually not done. A lot of times in this class, we're using multiple of our tools to get these polynomials into different shapes. We call it polynomial gymnastics. This is a combo in a way. Not only are we doing GCF, but we're now also going to have to go back to something we've done on the past 2 tests for this class. The last questions have been factoring a quadratic, right? So how do we factor this quadratic? What I mean is, how do I get it into this form where it's going to be 2 binomials? Well, if you've done well on that and you've been practicing that and done really well, you take the 18, you break it 1, 18, 2 and 9, 3 and 6. Which ones add to get you this -9? Well, that would be 3 and 6. However, I need them both to be negative. So these are the factors that add to get -9, multiply to get +18. So it's x minus 3, x minus 6. So there we have our answer. Let's see if Delta Math likes it. Okay. Let me go over to it. Here's our answer that we got. Delta Math's being a little slow. I'm sure some of y'all have experienced that. All right, here we go. So -5x parentheses x minus 3, x minus 6. So I want you to think about this. That took me a little while. Of course, I was explaining it, but that takes longer than 20 to 30 seconds to do, like every time. All right, so there is absolutely no realistic way that you'd be doing these in 20 seconds, 16 seconds, 30 seconds. Some of you maybe could do it in 30 seconds once you got really good. But again, that just to me has shown that you're not genuinely learning the concept, and the help that you're getting to do that is actually hurting you. Okay, let's submit this. We got it right. Okay, greatest common factor, -5 and x. You factor the trinomial here that we got, so you have to be prepared for that. That's one of the reasons we want to factor out the negative. Okay, that's a big part of that. Okay, and then we end up with our answer here. All right, so that's going to be it for this lesson here. We are at 27 minutes. So make sure that you practice those. If you have questions, reach out to me, and look forward to another lesson probably uploaded very soon.